Ooh, good morning. I think Siam's, you're the host this time, Siam. I'm doing the demo. So if you want to host and say hello and
Hello, everyone. Yes, I will. Hello, everyone, and welcome to the vCluster office hours. Uh, you have seen both of us probably if you have visited vCluster YouTube channel, but if not, then I'm Sayam Pathak, and I'm working as a principal developer advocate, and Mike, who is working as technical marketing, and yeah, we love to tinker around with bare metal, Kubernetes, GPUs, CNCF technology in general. So you are in the right hands if you want to ask something or learn something new. And yeah, we are also here to learn, so we are here to learn together.
the
And
hype train around AI seems to be growing, right? Like, I mean, you look at 2 or 3 years ago, everyone's like, no, I don't like that. But now it's like everybody is like changing their story, talking about how do we empower this stuff. I mean, Nvidia getting great sales year after year after year, and you're like, oh, this year they're gonna miss it. It's like, no, they did better because everybody's buying these up, right? Like you look at
stacking,
Microsoft and
they're
OpenAI,
stacking
like
AI.
investing into CoreWeave. Well, here we are. We're talking about AI today, or at
Yes,
least LLMs and
finally.
stuff.
Yes, finally you'll see a lot of, and from now on you'll see a lot of GPU stuff, a lot of AI things, because vCluster, our solution, fits very well in the GPU use case. So we'll probably talk more and more about this particular use case. And yeah, I'm happy to learn so many things. And yeah, Mike has some wonderful demos prepared for us today, so it should be fun. But yeah, let's get. I want Mike. I want to set the context first, like where we are with respect to the wave and where this thing is, what we are
Yep.
talking about, so that it's something setting the context type of thing.
Sounds good. So that's what your slides are going to be. You're going to talk about what I'm doing in the demo. Oh, here you go, slides.
Yeah. So basically, like Mike said, the right now the wave is crazy. Like even the people from the era who didn't have mobile phones, they are using chat GPTs. That's how big the impact is. Like, the older generation, like very old generation, they know about something which is fancier. Like it was Google previously,
Yeah.
now it's chat GPT. And whether irrespective of whether you are in tech or non-tech, people know about this. Kids know about this. And when a technology touches such deeper roots, it means that it is creating waves, impact, and it is on to something big. Which is what every day you wake up and you see a new news, a new AI model, something new announcement in the AI ecosystem. Like, it's very hard to keep up. I only thought that it's hard to keep up with the CNCF ecosystem, but well, AI is even moving faster. So AI ecosystem is ridiculously faster in terms of models and the use cases and stuff. But let's try to understand the crux. So AI was before in your lives, before everything went viral with ChatGPT Wave. So you have been shopping, you are discussing with your friend something, and suddenly the ad pops up. Everything is, kind of everyone is listening to you, and then they're recommending based on what you are saying, what you are thinking, and what other people are doing. For example, if you go to a store or if you go to a website, what you are buying, and then what your friend is buying, and what they are buying will be shown to you. What your friends is watching, they'll be shown to you. What food you are ordering, what your friends are ordering, and whatever they are ordering will be shown to you. So it's basically the basic recommendation systems have been in place for a long time. Movie recommendations. So it's been there, and unknowingly, knowingly, we all have been using AI, whether we are into the machine learning ecosystem or not. So obviously this wave, the generative AI wave, definitely I would say there was this ballpark movement when ChatGPT blew the world by a super knowledgeable brain which is there, and you just ask and you get the answer, and people were, wow, what the heck is this thing? Like, I ask anything, but you used to ask that on Google too, but that's the point. It's not something that is searching from the
Yeah.
internet. It is
Like
trying
Siri
to,
or Alexa, right? Like
yeah,
we're used to that. We're used to 10 years ago, like, oh, Siri's gonna be amazing. And it's like, I just don't even use it. Right. Like, it's
yes,
always the person like at like a hotel when you're traveling that's just like shouting into their phone and you're like, what are they doing? Why are they doing this?
yes. So that was the point where I feel the tipping point was the chat GPT. It acted as like when we used to talk, like when we talked to chat GPT and when people started talking to it, they were blown away because it was able to generate responses. It was able to generate new content. It can be hallucinations. It can be, when if you ask ChatGPT to write a full-fledged code, it'll give you, it'll work or not. That's the second step. Like you have to try out and things like that. But it gives you a very confident answer with a disclaimer that it might not be true. But it is trained on a huge chunk of internet, and it was trained on well put data. I would say the data is key over here, and it's so many people think suddenly ChatGPT came. No, ChatGPT is not the revolution. The revolution has been going in for decades, not even years, decades. The algorithms have been there for decades, not years. The research has been there for 60 plus years. So it's not something that ChatGPT did miraculously something in a day or two. It's been years and years and years and years of research that has led to this particular point. So let me just break it down, the basic terms on AI. So AI is basically creating those intelligent systems that can reason well. The reasoning is still questionable, to be honest, whether they are able to still fully reason or not. But yeah, still, as an AI that we want is something to build a system that can reason and learn and show human-like capabilities. Like I'm talking to Mike, what we want and what people are saying we are going to is that I'm talking not to Mike, but Mike's clone.
I'm an avatar.
With Mike's voice and with Mike's attitude, and it's not Mike. So that's where like things are heading to. Like 11 Labs is there. They can they're very good at cloning your voices in different slangs and things like that. So there's all sorts of weird stuff happening in the world. But yeah, AI is basically creating those intelligent systems, and machine learning, which is a subset. This is where this is important because this is what the ML engineers do. Training a model, like creating a model that is capable of answering. How do you create that? It needs a lot of data. What type of data? That can be supervised or unsupervised data. What is supervised or unsupervised data? Supervised data is basically something that can be labeled. For example, it's a cat image, so you can label that it's an animal, it's images of cat. It's a dog image, then it's an animal, and the image is dog. So you can label that particular data. Now, when you are able to label that data, you give 1,000, 2,000, 3,000 images. The model is learning, and the next image, which is not from the training set. Now, try to understand this. The next image that I gave, which is not from the training set, based on the previous data that it is trained on, it should be able to predict whether it's a cat or not. So that is something we are training the models for. That is the supervised data. But on the internet, everything is not supervised. Like everything cannot be labeled. So there is a huge chunk of unsupervised data, untagged data. And here there are like clustering algorithms and stuff that takes into picture. Maybe you'll understand it with the help of an example. Spam emails is pretty easier to understand. Like you all use Gmail and stuff every day, tens, 20, 10, 20, 30, whatever the numbers is with respect to your Gmail accounts. Everything goes into spam or junk folder, how it goes, because the data has been trained on a labeled data set where it has been tagged like this email is spam, this is not spam, spam, not spam, using what? Certain keywords like words, email addresses, and so on and so forth, blacklisted servers and whatnot. So the model will be able to predict spam or not spam based on the input and the training data.
Which previously was like based on filters and stuff, right? Like filtering based on multiple hits, right? Like you'd have to have like a scoring system before.
Yes. Next one is very common, and this actually represents the unsupervised learning data, where you group the people on the basis of clusters. I'll give you an example. Let's say you walk into a Walmart store and you bought something, or maybe you not in the Walmart store but the website, and you bought something. and you spent X amount of money, and you are coming in maybe monthly once. So what it does is it groups you with another set of customers with same purchase type and frequency and the purchase spend, so that it can cluster you with that user. And now in that particular cluster who has similar budgets, who are buying similar frequency, so when they cluster it, next time you go to the website, it will start showing you the recommendations of those clustered group of users. And that's how people do targeted campaigns. Model is able to recommend products to enhance customer experience. So that is something which comes from unsupervised data, and clustering is something that gets done. Another part in the whole AI ecosystem is another subset of AI is like it's subset of the machine learning actually, which is the deep learning. So it uses neural networks. Like many people say that it's a human brain. That's why it is, neural networks. It's like neurons that are connected to many data points. And interestingly, Chat GPT is subset of um, deep learning, because one of the fundamentals of Chat GPT is generating AI, generative AI. So it creates those new data points. I think I should have it somewhere. Let me see if I have it. Yeah, it should be the next slide, hopefully. And yeah, by the way, this deep learning works on both labeled, unlabeled kind of data. That's how it looks like, the Venn diagram. Yes, AI that generates video like text, image, video, creating new data points. So it tries to create those new data points. That is the whole crux. Now, the models that it used, the neural networks and the models are very, very old. Now, if you search for hidden Markov, you'll know when it first came. MCMC, variational autoencoders, VAEs, GANs, normalizing flows, diffusion models. These are not new. They are just getting improved with the better data. Garbage in, garbage out. So if you give very sweet and interesting data, the outputs will be interesting as well. So the algorithms, yes, they have published as well. They have created new set of algorithms, how to innovatively, and the infrastructure has grown over the years. So we now have that power to kind of do this. And we'll come to the power, because that's the main source. The GPUs are the main things that we are here to talk about. So these are some of the models that you might have heard on. We have text modalities. So these are called modalities. We have text, which is LLM. The model is LLM, and the application is ChatGPT. Image, the model is diffusion. The application is DALL-E. For video, you have diffusion. You have LoRa, VO3, Runway ML, and so on and so forth. And yeah, everyone kind of uses Kubernetes. So that is, now I'm coming to the point of how people train, deploy, and do all sorts of things. All these big companies, they use Kubernetes. You can see OpenAI, they scaled to 7,500 nodes. There are KubeCon keynotes that they gave in 19, 16, somewhere around that time frame, on how they are scaling their infrastructure, and their infrastructure solely relies on Kubernetes. That's a big thing. Take a pause and think about it. The application that is helping you write your tweets, the application that is helping you summarize some stuff, or helping you write blogs, or answering your questions, has been trained. The models has been trained on Kubernetes. How powerful the base infrastructure is. So inferencing is one part where once you train your model and you want to make it available for the internal teams or customers, so you do AI inferencing. That's the whole pipeline, right? So you do data collection, verification, configuration, feature extraction, ML algorithm. So a robust machine learning system includes all these things, and beyond deployment, monitoring, CI/CD, the pipelines, ML ops. So how this happens? This can only happen on a system like Kubernetes. Doing it individually, individual components, is pretty tricky, only on the machines or virtual machines or bare metal GPU instances. So dynamic scheduling of GPUs, unified control plane, scalability, and the whole tooling ecosystem, because it already has schedulers, it already has how to run multiple schedulers, which is something we'll cover on 26th. We have a webinar coming up on 26th, where I'll dive more into very interesting things like Run AI, Kai Scheduler, and the multi-tenancy models and stuff in detail. But yeah, this is how the crux looks like. Why AI, where we are. We are doing everything on Kubernetes, but still there are some challenges on Kubernetes, like tenant isolation is a challenge on Kubernetes. If you are running GPU or CPU or any kind of workload, then the fairness, how different teams kind of use GPUs. Now GPUs are very expensive, and also they are very hard to get. Like I was creating a GKE cluster. It took me more than 30 minutes to figure out which region actually has a A100 available. I tried to create, somewhere different zones, Asia, US Central, US East one, and stuff like that. But there are no GPUs available. So GPUs are at scarcity, and then GPUs are very, very expensive. So we want GPUs to be used at full capacity. The problem is the regular scheduling techniques doesn't work immediately very well for the workloads. For example, I don't know if I have that slide, but for example, if you have a training data set, if you want to do training for a very big model that takes 200 300 gigs of memory, you can't do that on a single machine. You have to split it across different pods, let's say 3 pods running on 3 different modes. But the catch here is they all have to run at the same time, then only the training will be successful. That happens when you have this is called gang scheduling. Gang scheduling is not done by the regular Kubernetes scheduler, which is why whenever you see people using Kubernetes, and whenever you talk, like go to KubeCon, any of the KubeCon talks on of Nvidia, they'll talk about the scheduling mechanisms, which is very critical in machine learning workloads. Someone will talk about Q, someone will talk about Volcano, someone will talk about Kai Scheduler, someone will talk about Run AI. So these are very interesting because they help you to first utilize that GPU in the best way possible, and then schedule it efficiently so that you can do the training, and you can cut your training job into different chunks, but running at the same times on different nodes in the Kubernetes way, the gang scheduling thing. So that is something that also you can only do on, obviously.
Yeah, your round robin doesn't work in that way, right? Because round robin is just going to put it wherever, right? Like, and there might be like something that's going to take up a lot of time on that GPU that's running ahead of it, and then like it's just not in sync anymore.
Yes, and also these days, the LLM models, like people are running their LLM models on Kubernetes. There are a lot of reasons for that, like security is one big, and they want everything closer to their infrastructure, so bare metal and GPUs running as fast as performance as they get near to what they are doing, because there are some key tasks that has to be performed using those machine learning models with a specific training set specific to the organization. That's where these models are then trained and deployed on a system like Kubernetes, which is what my man Mike will show today, along with multi-tenancy.
Let's do a little demo. Yeah. So like the inner vCluster, right? So this is like the start of like what we're going to start showing with like vCluster and how you can do multi-tenancy and stuff with GPUs, right? So why didn't this take off a couple of years ago? It's because before that, like it was one pod to each GPU, right? Like, which that's very inefficient. It's hard to schedule things when that's happening. But then Nvidia made it so that you can do time slicing. They have multi-instance GPUs and stuff like that. What we're going to show today, let me bring my screen up, is we're just going to show time slicing. Time slicing is going to be a little bit easier to mess around with at home and to do other things with, right? Because all GPUs are not created equally, right? Like, a lot of people will be giving a little bit of blowback for the new 5 series Nvidia stuff because the memory that came out originally with it was 12 gigs. Now, what kind of model is 12 gigs going to run for you? Not a very large model. And what does that mean? If you're not running one of the larger models for LLM, then you don't have as many training points, which means that you're not going to get as good of results as you would get with a larger model, right? So like that biggest DeepSeek one that's like 400 gigs would be great to be able to run it at home. Probably can't run it at home unless I've got like a bunch of GPUs set up and I can actually spread it across them. But the difference between like a GPU that you're running at home is going to be like the one that I'm going to show you the demo on. It's 16 gigs of memory, right? Macs have a lot of memory too, and you can actually run it locally on a Mac, and it's a little bit closer to the GPU. But 16 gigs of memory on this 5 series GPU, which is like $800 or $900, right? The A100s start at 40 gigs of memory, right? Like, and that's like $4,000 to $5,000 used. So you see the orders of magnitude, it's more expensive. They have more memory. You can do more stuff. You can load larger models, right? But still that 400 gig model is going to take you maybe multiple GPUs, or it's going to take you like very, very top end GPUs, or something with a very fast backplane where they can all talk to each other very quickly, right? So where does vCluster come in? vCluster comes in like, hey, I've got GPUs. I want to go ahead and set up, my users to use GPUs. Very easy thing, like using maybe LLM, or maybe I want them to have code completion, or I want something like that running in VS Code. Well, that's what we're going to kind of show today. So some of the requirements that I already did before this is you need to install on. All right, so this is a Kubernetes, a K3s node. It's a single node with a 5070 and GPU, right? So what I've installed previously is I've installed a Nvidia driver, and that's going to be specific to what you're running, like server version or like the desktop version. I have installed the Nvidia container toolkit. So those are two things I've already installed. I'm not going to walk through that because Nvidia's got good documentation on it. You can just create that, or you can install that on the cluster where your GPU is, or the node. So what we're going to start out with is I've got my kubectx. So I'm looking at my AI node, right? I got my AI node. And this little thing we're showing off, this is RunMe. One of our developers showed us this recently. If you're looking for a way to do demos, pretty cool in VS Code, it's called RunMe if you want to know about that. All right. So on my base node, what I need to start out with is I need to install the GPU operator from Nvidia. I'm using the latest version. I'm going to create a GPU operator namespace, and then I'm going to install the operator. So let's go ahead and run that. And while that's running, we're going to install, okay, so we're going to install it on the base cluster, and then we also need to install it in the vCluster. So there's some considerations if you're running a vCluster, if you want to run this. Like this would, if I'm just running it on the base node and I'm doing namespacing, I'd stop here for the most part. Well, I'd set up time slicing, but I kind of have to stop here. But there's no, like, there's no values that I'm stopping from being installed. I'm just installing the base thing. I'm not turning anything off. Now, with my GPU, I don't have MIG support. That's going to be a data center based one. What I can do though is I can do time slicing, right? And sometimes you're going to have people actually set up time slicing with multi-instance GPUs, right? So they'll break up a GPU into like 4 GPUs, and then they'll time slice that up, right? It's kind of like hyper-threading or something like that almost, if you want to compare it to that. So I have one GPU here. What I'm going to do is I'm going to set up 4 replicas. And what does that mean? That means that I can have a single GPU, but I can have 4 workloads attached to it, right? I try to create that 5th one, it fails, right? So this is what the time slicing configuration looks like. What we're going to do is we're going to go ahead and create, let's show first that we don't actually have, we have 1 replica and 1 GPU. Let's go ahead and create that time slicing. And then what we have to do is we have to patch it, right? Like weirdly, we have to patch the operator because it doesn't automatically pull that in. It's in NVIDIA docs. So we're going to patch it, and then we're going to wait a minute till the actual GPU replica count goes up to 4, which it takes a minute because it's patching. And then once we're up to 4, what I'll do is I'll show you a quick, like, let me create 4 workloads real quick that are going to access that, right? So if I created 4 right now, 1 would run, 3 would fail because there's only 1 GPU available. This takes a minute. Actually, maybe I can show that off while it's not done. All right, so let's verify time slicing. This verify time slicing just creates like 4 workloads. If anyone has questions while we're doing this too, oh, it updated. If anyone has questions, let us know too. This is interactive. Well, it's not giving me the updated information, but it is letting me run it. So there are 4 GPUs running. Otherwise, this would get deleted. Live demos, right? Like I've done this like 50 times now before this just to make sure everything works. So let's hope that everything runs. Up there we go. GPU replicas 4. It was just taking a second to come up. All right, so we ran 4 workloads that are actually accessing the GPU. If we look at it, this is just like what they show off in the NVIDIA docs to run to show that you're actually able to do it. All right, so that's interesting. I can do that on the base cluster, but like what if I want to do multi-tenancy and stuff and I don't want to do namespace isolation? I want to give each user like their own Open WebUI or something like that. That's where vCluster comes in, right? So vCluster adds multi-tenancy for many different Kubernetes workloads and stuff. GPU stuff is no different, right? Like I just need to be able to tell the vCluster, where to deploy these things. Like right now, I've just got a single node, but I could set up multiple nodes and use labels and select different nodes for the vCluster to deploy there. Like if I want to, give people certain access to things. So what do I need first for the virtual cluster? For these resources, I'm going to expose them with Ingress. So I need to make sure that I've got a load balancer. This is all local. So right now I'm running Metal LB. This is my load balancer, this IP address here. I have created DNS for these. It is just an Etsy host, right? Because I'm doing everything local. if you're doing something, you know, on-prem or something like that, you're gonna have a DNS provider that you'll be able to add stuff in, and you'll do like your local host names in DNS. All right. So what I can do now is I can create a virtual cluster. Right now I have 0 virtual clusters. I'm going to create one. The thing that's different about doing this compared to just deploying a regular vCluster is I need to make sure that I can see the nodes, right? So I have nodes enabled true so that I can actually see the nodes on the host cluster to be able to verify what they're able to do. That way I can actually deploy things and say, hey, this is a GPU node and you have access, right? Because I need to have that GPU operator installed, and I need to have the runtime too. All right, so let's go ahead and create this virtual cluster based off of this configuration file right here. We're going to create the virtual cluster. It's going to take a minute to come up, which will give us a second. I know I'm just talking I'm probably talking a little bit too fast, so I'll try to slow it down. But anything you want to ask while this is happening there, Siam? Any questions? Nothing. Anyone else have any questions about this too while this is deploying? It's take like about 30, 40 seconds.
Yeah. So, so if you can explain, hello, I'm audible now?
Yeah, I can hear you.
Okay. So why we are using vClusters over there? Like what's the use case?
Multi-tenancy, right? So everything that we're talking about with vCluster basically is going to be multi-tenancy. So say I've got users that I want to give access to the GPUs, but like I don't want to manage Open WebUI or something like that and have multiple users in there. Let me just give them their own Open WebUI so they can download their models and then they can mess around and they can connect it to their VS Code or something like that if they want. So basically multi-tenancy, but then also being able to just pack more people on without using namespaces, right? I can do more to this vCluster than what I've done here to lock it down and add quotas and stuff around it and add like network policies and that kind of stuff in the namespace. I can lock it down a little bit more and give them their own API endpoint instead of having them just deploy on the base cluster, right? So the same reasons why you would use vCluster on a regular Kubernetes cluster without GPUs, right? You would use 4 GPUs. Maybe they need to install their own CRD and it's different than what another user wants to install, different version, because they're testing something, they can do that, right? If they just are all in the base cluster in the same namespace, there's the global CRDs, they can't install different ones. So like the big upsell is going to be like multi-tenancy, but then there are other things that you would possibly want to use it for too, like to be able to, you know, secure things. Like something else that we've created is called vNode. You want to like lock it down and make it so that you can run stuff without giving. It depends on how much you trust your end users, right? Like if you don't trust everyone that's running on there, you want to lock it down so they can't get to the host cluster, and you want to add more stuff around it. So vCluster kind of gives you a way to containerize that, kind of contain them within their own thing instead of them just being on the base cluster, right? It's also easier to create these and then delete them and get rid of resources and stuff instead of spinning everything up on the base cluster. All right, so let's look at our kube context. We are connected to our vCluster. And now what we're going to do is we're going to install the GPU operator on our vCluster. And we're going to set a couple of things off, right? Like we don't need the driver enabled here. We don't need the toolkit enabled here. We're just going to use that from the host cluster, but we need to at least have some of these things in the vCluster so that we can access them. Now, one of the other use cases you might want to do is you could probably like sync that stuff up from the host cluster instead. Maybe that'll be our next demo, but that's going to be more of like an enterprise demo. Everything I'm doing today right now is with vCluster open source. None of this is using enterprise or anything like that. So you can use vCluster open source to deploy a lot of this stuff. We're gonna have some nice to haves, obviously, in our vCluster platform, which is going to be the enterprise. All right, so I've created the operator. Now, if I look here, it might give me the wrong replica count. So here again, I just do the time slicing, and then I patch it just to make sure that it doesn't overwrite what I have previously configured, right? And if you want access to this demo and stuff, we will add it to our GitHub repository, and I'll add it to the link on the video. I need to clean up some of the text on it and make it a little bit more professional so I can share that out. All right, so now what we've done is we're in the virtual cluster, right? Get namespaces. We've got like the GPU operator. We've got basically nothing from the host cluster. We've installed that. We're on the base cluster. Let's go ahead and see if we can run that demo again. Or we're gonna verify time slicing. Make sure everything's running again. So we have 4 of them, right? Like if I change it to 5, 5th one's gonna fail. So let's delete it. And then what I'm going to do now is I'm going to do the fun thing. I'm going to install Open WebUI, right? So Open WebUI is just something that I was messing around with instead of like Hugging Face, because I just wanted to deploy an LLM and mess around with Ollama, right? Like there's a bunch of other options out there that you're going to use, right? Like we'll have more details about how to configure and set those up, but Open WebUI is a very good first example of how to get stuff going, right? Like I'm just going to deploy this UI. I'm going to give it to my user. They're going to be able to access it. They're going to be able to go through Ollama and download different models and be able to use it there. All right, so what I've done is I've installed Open WebUI. I'm making sure Ollama is enabled. I'm saying GPU is enabled for Ollama so that Ollama doesn't use the CPU instead. And I'm saying, use one GPU. And then the type is NVIDIA and the runtime class is NVIDIA. All this stuff's in my virtual cluster after deploying the GPU operator and making some of the changes. Now, I'm going to expose both my Open WebUI and I'm going to expose Ollama. One reason I need to expose Open WebUI so that I can actually go to the UI and interact with it. And then I need to expose Ollama so that I can attach something to that, right? Like, it's cool that I can go into the Open WebUI and do chat and all that stuff, but I want to do more than that. I want to connect it to VS Code. So I'm going to create some, you can read the question. I'm going to keep going through the demo, and then if you want to read the question in a second, Sam. Actually, let me read it. Exploring Kubernetes service, namespace service, container service. How do I get in touch? Okay, yeah, so Simon, you want to post the Slack, and I'll just keep going through. Slack's probably a good way to get in touch, or like reach out to Siam or something like that on LinkedIn, or like I said, Slack's probably a good way to get in touch. I'm going to keep on pushing through the demo. All right, so I've created the ingress for this, which will give me these endpoints that I can actually interact with. The important one is the OTS one for being able to hook up continue, right? So after I've got both of these running, I'm going to connect continue using VS Code as one of the plugins and kind of show you how you can use this for your developers, right? All right, so let me open this here. All right, I'm going to leave that there. All right, so this is vCluster 1. I'll leave that there. And now I'm going to disconnect and I'm going to do vCluster 2, right? Because it's more interesting to be able to have multiple virtual clusters connected to the same node, the same GPU with more replicas so that I can give, 4, 10, 15, 20 different people access to the same node and GPU to interact with it. Time slicing, maybe not as efficient as like a multi-instance GPU, but if you don't have something that is supported with that and you just want to do time slicing, you can get started here, right? Like maybe you've got a bunch of like consumer grade 3090s or something like that. You can do time slicing with this and it'll let you run multiple workloads on that same GPU and get more usage out of it. All right, so disconnected. Let's go ahead and check the context again. We are on AI, which is the host cluster. Let's create the vCluster 2. And we're going to basically do the exact same steps that we did on the first vCluster. After we've got these deployed, I will bring up Open WebUI. I'll log in. I'll show you that they can both. The magic thing is being able to run a request in both of them at the same time and see that they both give results. Because if you didn't have time slicing on, it shouldn't give you both. Obviously, it wouldn't run first of all, but it's not gonna query at the same time in like a 1 2 1 2 1 2 1 2 or anything like that. It's gonna error out. All right, cool. So we got that. We're connected to our second vCluster. And now what we're gonna do again is we're gonna install the GPU operator with a couple things disabled because we are in the vCluster, which is a layer up. We don't need to enable the driver or the toolkit or anything like that. That's done on the base cluster. And then after that is running, we'll create the time slicing thing again. The time slicing is, like I said, it's going to break it up into 4. Now you can break it up into more than 4, right? Like I'm sure at some level, if you broke it up into 50 or something like that, there's going to be some slowdown in results, which, you can cross that bridge when you get there, get another GPU and then add it in there. All right, so we're going to do our time slice again. We're going to patch. And then we are going to describe, which is going to give us the 4. Let's go ahead and do our test again. So this verify is very good if you're trying to troubleshoot. Like if you're trying to troubleshoot, why is my time slicing not working? What I ran into most of the time was that for some reason when I was installing, since I'm installing the GPU operator multiple times, I'm installing in the vCluster and I'm installing it on the host cluster. Sometimes I would get like an overwrite of how many replicas were available and it would just switch to 1. And then I couldn't actually run anything because even though I had 4 replicas available on the host cluster, it didn't recognize that. It thought I only had 1 because I'm running the operator multiple times. But like I said, the enterprise stuff probably end up sharing that up as like a CRD, but there's more resources than just that are in there, right, for the operator. All right, so we've got the 4. Let's go ahead and we're going to create. So this time we're going to create with the verify, and one of them is not going to run. We should have, 3 running, and then 1's not, right? And this one's not running because it can't find a node for it, because we've only split it up into 4. So that would be number 5, right? We've got Ollama running on our vCluster 1. On our vCluster 2, we're trying to run these 4, but we can't run this one. Let's see. Because insufficient nodes, right? Now, if we had 8 replicas, we'd be able to run that. All right, so let's delete that. All right, any questions? Let me know if you got any questions too. Like I'm kind of going through this quick, but I said like I will make this available later so that if you want to mess around with vCluster and you've got GPUs and stuff, you can do that. All right, so we've got that running. Now what we're going to do is we are going to install Open WebUI. All right, so when we verify that we at least have the GPUs that are available so that when we install Open WebUI, our pods shouldn't get stuck. They should all be running, right? So the most annoying thing with this when you're testing out is this thing will just get stuck because it doesn't realize that there's enough GPUs. But as long as you have the replica count and everything running, it'll be fine. I think that's what I spent the most time on is for the second vCluster is making sure that it was able to see that there were 4 replicas, because for some reason, like I said, overwrites. And if there's only one replica available to the vCluster, it's going to see that other vCluster is using it and it will not deploy. So it's very important to make sure the time slicing is working. All right, let's get our ingress, make sure that it's running. It'll take a second to get the results. And then what we'll do is we'll open that up and then I'll kind of show what Open WebUI looks like and how we'd actually use it, right? Now that we've actually got them running in a vCluster. Let me actually go copy this real quick. We're just going to use Gemma 3 4B, which is small, right? Like I said, I've got a 16 gig memory there. I can't really load anything too large. The results aren't going to be amazing, right? Because you want much bigger models if you want the good results. All right, so now we got 2 Open WebUIs, right? Got TS1, vCluster 1, TS2, vCluster 2. Let's go ahead and create our accounts real quick and log in. If it's the first time you're seeing Open WebUI, it's a great thing to use to be able to like just kind of get started and see how this stuff works. It can hook into Ollama and a bunch of other things. I'm just using Ollama now because I wanted to mess around with some of the LLM. Let's go here and then create this account. And then I'm going to come over here and on this one, I'll create this account. Right, like this would be like user 1 and user 2, right? Like you've given your users access. Let's go work account. Right, so basically we've got these 2 versions of Open WebUI. Now, like why would I want 2 versions? You probably don't want to really, like who wants to sit there and manage something like Open WebUI and like add users and manage all that stuff when you can just be ephemeral and just give your users access for however long they need and they can create it on their own, right? Like it doesn't take up a lot of memory. It's not like, huge overhead or anything to run this, right? Like the thing that's going to take up all the storage space and all that is going to be the models. All right, so within Open WebUI, I don't have any models loaded. How you get models is you go to your admin panel and then you come over to your settings and then you can see I've got connections. So I've got Ollama, but I'll go to models and then I will download my models. So go here. Now you can see all the models you can download by clicking here. It's going to take you to the Ollama library. You can do DeepSeek, Gemma, Quinn 3 and all that stuff. I'm just going to pull something very small because I've already configured my continue to use that. So sorry for waking everybody up with the bright screen. So let's download that one. And then in my other one, I'm gonna do the same thing. Go to my ads, go to my models, and I'm going to download that same model in my other virtual cluster. Now your users are probably going to use different models, right? They're not going to use the same model. I'm just kind of showing something that's smaller and using the same thing. All right, so once these are done, which is going to take a minute, before they're done, I'll show you like a chat real quick. I'll show you that they're both able to get the results at the same time. Because developers might be asking you, hey, can I get a, or like, what can we pay for to do code completion? But if you've got your own GPUs, you can give them and they can start using it, right? Like you don't necessarily even have to give each user their own Open WebUI. Maybe you're deploying different things in different virtual clusters and you're able to put like a much larger model in there. And then you just have an endpoint for them at that point to where they can just access it over that, right? Because all I need is that endpoint. Now how do I do security? You might want to add some kind of auth or something like that too, because you don't want to just be like serving up this model to anybody that can consume it with that endpoint. All right, so cool. So we got Gemma 3 4B over here. So that one's done. Let's go ahead and close this out. And then I think we should also have it over here. All right, so let's go to new chat. And then I'll come over here for new chat. Let me split these up so you can actually see. All right, cool. So here we go. So we're vCluster 1 left, vCluster 2 right. And our cool demo is, what should I ask? What am I asking it today, Sam? What is vCluster in a word essay? Something ridiculous. So that way I can actually have it run for a minute. All right, and then boom, boom. Here we go. So it's time slicing. So what it's doing is both of these are accessing the same GPU. Okay, cool. Yeah, both of these are sharing the same GPU, right? Like, and they're both working, 1 2 1 2 1 2 whatever with time slicing. So they're each getting access and they're coming through and they're working. It seems so easy, right? But like that's the thing that changed in the last couple of years that made everyone say, hey, I'm going to use a GPU cloud. I'm going to do these things. I'm going to get my own GPUs. I'm going to buy them. I'm going to use them. Because previously, right, like I don't know how many years ago, I don't know when, I think Nvidia like 2 or 3 years ago released, I guess, the toolkit maybe. I don't know, Simon, what the time frame was. But before that, you're looking at one container to one GPU per node, and that sucked, right? Like, so that's why people were probably using VMs for everything, because they could then do pass through and stuff instead, right? Like, and run multiple things there.
And that's expensive.
Very. Right. So, okay. So now, what have I shown in the demo? I've shown deploying the GPU operator on a host cluster. I've shown deploying 2 virtual clusters, deploying the operator there, and then connecting both of those virtual clusters. All right, let me actually show you. Like, you're like, oh, he's just making it up. All right, so if I go here and let's do it again. All right, so this is actually on my GPU node, and I'm looking at my GTX or my RTX 5070 Ti. I've got these 2 models loaded, right? Neither of them are doing anything right now. They're what, 5 gigs? Neither of them doing anything right now. Let's go ahead and make it do the same thing again, right? So let's go this, see if it's fast enough. And then let's go back, right? Like, and now I'm seeing it in the background. You can see the stuff running, but now I'm seeing like the actual usage on, right? Like, so these are literally both hitting the GPU at the same time. Pretty cool, right? Like in the production world and stuff, you're going to have much larger cards. You're going to have much more workloads running on it, and you're going to be able to actually do multi-instance GPUs, stuff like that. But like time slicing is still something that you might do on top of that. Cool. All right, now let's go over to VS Code. What's interesting about that? Not a lot, right? Like, I can just kind of go ask it questions, and I can use it as my own personal chat GPT. But what your developers probably want is, how do I use that in VS Code or my IDE and get my code completion and stuff without using Copilot or something else? Maybe you want to save your information, or maybe you want to train a model on something like your own GitHub repository so that you can actually have code standards and that kind of stuff. Oh, Simon's back. Let me add him. There we go. Maybe you want to like train it on your own data sets, right? Like, and you want to make sure that you don't share that with everybody else. That's why one reason why you run it locally, right? All right, cool. So now let's add it in. All right. So I turned off my extension because it was bugging me like nonstop because of this cluster. All right, this cluster is also my gaming computer, right? So it's a mix. It's a mix of my gaming computer and then my K3s cluster for just kind of like showing demos and stuff like that, right? So sometimes it's on Windows, sometimes it's on Linux. So right now it's on Linux. We got continue. What do we want to do with continue? We've enabled it, and now what we can do is, let me bring up the configuration so you can see it. All right, so we'll go back to the beginning here. All right, if I go to my configuration for my continue, it's just this. I'm literally using from the first virtual cluster that ingress endpoint that I was talking about for Ollama. I've connected it in. I've told it that I want it to do, code, and I want to do autocomplete, chat, embed, edit, apply, right? So now within VS Code, I should be able to connect to that thing that I just deployed. Let me go over to continue. Right down here. And let me make sure that I'm on the right assistant. Yep, Gemma 3B. Yep. And then what we can do is something like, what is vCluster? And it's hitting it, right? So it's hitting it now. So this is hitting literally, all right, it doesn't have enough. This is a very small model, so it doesn't have enough information to do a lot. Like, what is Kubernetes? How about that? What is Kubernetes? So this is now hitting the Ollama endpoint that I've deployed in my vCluster, in addition to like WebUI, and it's accessing, or Open WebUI, it's accessing the GPU that I have sliced up with time slicing. Now, what else can I do, right? Like, let me come over here and let me Command I.
Mike, what about, let's say if anyone who is watching now or watching later, if they want to do this end to end, how do they do it? Like, we need more, right? We need more work from you. You have to prepare something for the people so that they can follow it end to end.
So what I'm going to do next is create an actual video of the demo outside of this, and I'm going to post this to GitHub, and I'm going to give you access to that. Like, I might just be able to post it the next day or two to GitHub, and then put it on this video link in YouTube so you can see it. Rapboy, yeah, this is right now what I'm doing is VS Code, right? So Open WebUI, if you're coming in like later, Open WebUI is over here. This is Open WebUI, right? Like this, and it's got like, you can chat, you can load multiple models. You can come in here and you can literally download anything, right? Like in your models. I deployed Open WebUI with Ollama. Like, you can deploy with other stuff. I think like Hugging Face and different things too, but I'm using Ollama for this. So this is Open WebUI. Now the endpoints that I'm using, like if you look at the settings, is actually like I've created an ingress resource to link to this, right? Like, this doesn't show the correct thing. I can modify it here, but I'm literally linking into this right here, right? So I'm connecting to the Ollama endpoint through Open WebUI to consume that model that is running here. So what that does over here is I can, like I said, I connect in with continue. I'm using that same endpoint here, OS1 vCluster.ai. And then like I can use it for code completion. Now you're gonna want a bigger model. Like if you're doing stuff that's complicated, you probably like, I'm running multiple models to show that I can on the GPU. But like if I was going to do this just to mess around, like as a dev, I'm probably going to load as large of a model as I can. This is close to the max amount of memory that I have for my GPU, right? They need a little bit of overhead still, but if I've got like a 3090 with like 24 gigs of memory, I'm probably going to be trying to load 20 gig models. Just the more the larger the model is, usually the more data points it was trained on, meaning the better results I should get, right? Like I should get better results, right? Now, how does that approach the chat GPT level? Not exactly, unless you can run something very large, right? Like Framework's coming out with a desktop later this year, should ship Q3, that's going to give you 128 gigs of memory, and it's going to be much closer to the AMD chip, right? The AI chip they have coming out. So that should be cool to run LLMs, and you can load much larger models. But 128 gigs isn't enough to run the largest DeepSeek. Like I looked up ChatGPT, and it said ChatGPT is something like a 400 to 500 gig model. So you're not necessarily going to be able to do that for local LLM and messing around that way, but you can get pretty close, right? Like if you can get close enough without spending that money and use your own stuff, home lab or whatever, or use your own stuff on prem, like it's going to be helpful. All right, so let me show continue real quick, and the create a Kubernetes deployment for Nginx with one replica. Boom. All right, so like that's literally using my GPU I've got sitting in the other room over there that I'm using for gaming. To be able to give me code completion and that kind of stuff without actually having to connect to something external, right? And then say if my wife wanted to use it, I could just connect her into the other vCluster, and then we could work at the same time and use time slicing and then not have to wait, right? Because if I connected her to the exact same endpoint that I have now, then it would do my stuff and then do her stuff and then do my stuff. But it would like, I think it takes like it doesn't happen at the same time, right? It doesn't happen at the same time in parallel. It would finish mine and then do hers. But that's basically like the demo. Like I said, I will put the demo information out. I'll add it to the description of this. By the end of the week, I'll have it by Friday. I'll even post what I have now without cleaning it up all the way so that we have something, and I'll post it on there so you can play around with it, right? Like the basics of it are basically you need to install a GPU operator on the host cluster, right? Like if you want the kind of steps to kind of play around with this before I get that up. You want to install the GPU operator on the host cluster. You want to set up time slicing on the host cluster. You want to patch it. You want to make sure that you've got the replica count and everything. And then within the vCluster itself too, you're going to do the same thing. You're going to install the GPU operator, but you're going to disable certain things because you're running in a virtual cluster. Like you're going to disable the driver, you're going to disable the toolkit. And then you're going to create the time slicing too, and you're going to patch it. Also, like I said, the big thing is you need to make sure that you're able to see the nodes. So you are passing the nodes up, right? Because if I look at my kubectx and I get nodes, I can actually, this is the real node, right? MAI, Mike AI. So that's the real thing, right? So if I go over to like AI and I can get nodes, right? Same thing, right? So you need to share that up so that it's able to see certain things. If I get, can get runtime class, and then grab Nvidia, right? So I've got these Nvidia runtime classes and stuff like that too, right? So I need to be able to have that runtime class so I can say when I'm creating my things, use the Nvidia runtime class and make sure that it's using Nvidia over using like the CPU, right? Because if you install this and you have a good GPU, but it's running super slow, maybe it's not hitting the GPU. You can check the GPU like usage and stuff like that. You just make sure that you're using the Nvidia run class. Okay, cool. So that's basically the demo, right? Like I'll post stuff later so you can actually see it if you're interested. But the idea behind this is you can use vCluster to create multi-tenant environments and give access to GPUs using time slicing. If you're doing home lab or you have some of the cheaper GPUs and you still want to use them, like maybe you're using them for like Bitcoin mining or something like that, and now you want to use it for something else, you can use those things. If you're using data center level GPUs, you can do the same thing, except what you're going to do instead of just using time slicing is you're going to use multi-instance GPU. So you'll enable that feature. And then you can split up your GPUs into multiple GPUs. But then, like I said, some of the reading I was doing was saying that people are using multi-instance GPUs, and then they're also using time slicing so they can get the most out of their GPUs. But then that's just all cool, but like it's not enough. That's the thing that sucks. Is like you dig into the AI stuff and the GPUs. That's not enough, right? Just Kubernetes with this isn't enough. So Siam on the 26th is going to be talking about using different schedulers, because literally you read anything about it, you're like, well, I can't just do the round robin scheduling anymore, right? That doesn't work. Like, what if I've got this long line of reasoning and this chat with this with this model, like this backlog of stuff, and then I get scheduled somewhere else, and none of that is cached anywhere, and I can't reuse that. That's a lot of wasted time, right? So you need to be able to schedule stuff to the same spot for some things. You need to be able to schedule things in a way that they're actually going to get finished and done in a way that's it's going to be helpful to you, right? So let me go ahead and stop sharing. If you want to share the slides again, Simon, we can do like the outro and kind of show some stuff off. But hopefully that demo was helpful. Like, this was a lot of fun for me to actually play around with and build. It's the start, right? Like, we're going to have more information and more stuff about how to do this, right? Because we want our users playing around using like the GPU operator and different things on vCluster. But yeah, if you have questions, if you want to ask anything about this kind of stuff, go to slack.vcluster.com. I'll do the outro for you, Simon. I know it's late. It's late there, and like you just had to watch me demo for like 30 minutes when I said it was going to be like 10 or 15 minutes. But thanks everybody so much, right? Like that's the start, right? Like if you have things that you're working on that are pretty cool, join the vCluster channel and like let us know. Maybe we need to make like a vCluster AI channel or vCluster GPU channel to where it's all GPU related, right? Like, we don't have,
a few things. One, if you happen to watch it later on, or if you are watching it right now, and if you can comment what you are using or what you are doing in the GPU space, that would be good. What problems you are facing, that would be good to know as well. And also what type of content with respect to AI GPU sharing vCluster you would like to see in combination. That would also be helpful. And also, if you can subscribe to the YouTube channel, that also gives motivation to Mike and myself. And then what else? If you can join the Slack, which is where we are, slack.vcluster.com, that would be good. And if you want an in-depth demo for your enterprise, whether you are scaling up on AI and stuff, you can go to vcluster.com/enterprise/demo. So yeah, we are doing these vCluster office hours so that you can be part of the main aim. So it would have been a webinar also, right? But the main goal is for vCluster webinars to be chill out. It's not that much formal, it's informal. You can ask us questions. We will try to answer with respect to best of our abilities. And that's what the office hours are for. For the most structured way. Yes, just want to share what Mike and I have been working on and learning with you all, and would love to learn what you are working on in this AI space, what you are learning. And then webinars are more structured, that you can join on 26th, which will be in a more structured way. But these are more fun ones where you can ask us anything. Yeah, hopefully keep it to tech, but yeah, still you can ask us.
And say some of you are better at this than I am. Like, and the odds are like a good amount of you are better at this than I am. The GPU and stuff like that. So share your learnings. Like, share your learnings. Yes. If you want to do something with vCluster, and you make like a blog or something like that about it, let us know, right? Like, if you want to make a video about it, go for it, right? Like, I'm gonna make videos about it and kind of talk about it and stuff too. But like, we always like seeing people make their own videos about this is what I'm doing. Like, it's so cool to see people use it.
Yeah, if you happen to actually, that's a good point. If you happen to write a blog or create a video, happy to send you swag as well. Like, why not?
All right, awesome. I think we're good. I think we went pretty much to time. I hope everybody enjoyed it and got something out of it. Thank you so much, Siam, too, for coming in. I'm acting like I'm the host. You're the host. You do the talk out. I'm just going into host mode.
Yeah, thank you all for tuning in, and make sure to do all the like, subscribe, share, and stuff. If you like it, do share in the comments. You love these kind of streams and would love to see them later on as well. That obviously motivates us to create more and more fun content for you. Yes, as Mike mentioned, we'll put this in GitHub Repository and in textual format and a separate formal video format as well, the demo part. And then 26th, we'll do more of tenancy models and stuff. So it should be good. Thank you so much, everyone, for watching. If you have any questions, Slack, LinkedIn, Twitter, or wherever you can find us, just message us. We'll be happy to help you out. Thank you.
See you later.